Welcome everyone to Chapter 8. It's starting, it's happening, it's all real. Chapter 8 is the biggest chapter. It's a long one. There's a lot of examples. So we're going to start off with a bit of an introduction, and we're going to go back to what's really familiar, which is iNZight. So that you can play along with this the context of this lecture, first thing I want you to do is to play a game. And it really is a game, this isn't a trick. So if you open this short link, do watch it as case sensitive. Type that straight into the URL of your computer, browser, whatever. And you will get this up on your screen. So this is the game. You can read through that. So for each round, you're going to be shown a word and you have to click or touch, depending if you're on a touch screen or not, the letters in the order displayed. And there's a few other questions that I'm asking you about as well. So your course and your current energy level. I'm feeling pretty tired and I'm going to say that I'm in stats 101. So when you start, for this one, this is statistics backwards. So SCIT, right? You get the idea. So play the game. There's 2 rounds. Once you've played, come back to the video and you'll see what we're going to do with the data from the game. Okay, so welcome back. So you might want to have a think about some of the data that would have been collected as you were playing that game. So some of it was quite obvious, so the answers to these 2 questions. But then in the game itself, a lot of other data was collected. You can see up here the time of day, the screen size of your device, the type of device, so laptop or mobile tablet. So that's all collected. But in addition to that, information about how well you played. So now again, so that you can play along with the next bit, pop this link into the URL bar of your browser. Again, case sensitive, so make sure those are capital Ds. And it will take you to iNZight with the data. So it should look a little bit, like this. Now the data won't look exactly the same as what I'm showing you. And that's because as you play the game, the data from your attempt at the game will be included in this data. So it's going to update as you play. But at the moment, I'm just recording it, so I'm using some old data from last semester. So we can see the type of device that you are playing on. We can also see some things about when you started, player ID, screen width. You can kind of see this is clustering or grouping. We've got bimodal data here for the screen width. Not very surprising. These are sort of all your smartphones and tablets, and these are your laptops. Well, actually, probably these are your smartphones. These are your tablets, because there's not very many tablets in the data. You can see just a couple. And then the larger screens are your desktops, laptops, what have you. So this person, a great big screen. Screen height, similar-ish, but not quite in the same way, because for a phone, the height is actually fairly good. But we've got a real grouping, so kind of your phones, tablets, laptops, and desktops. Canvas width and canvas height, that's how big the actual game screen was. So that would again depend on how big your actual screen was. So we can look at those. Similar kind of pictures. Device type we looked at, your course, energy level, which I also split to tired, which is just tired or not tired. level order. So you played both rounds. So you either got backwards and then forwards, or forwards and then backwards. And it's pretty even, those two, because it randomly generates which one you do first. And we can see which was your first round. We can see how long it took you to complete the game in the first round, or complete the first round. We've got how many clicks it took. And the distance that you've clicked. So again, this would depend a little bit on how big the canvas ends up, but there's quite a lot of stuff there. So we've got heaps and heaps of data, and what I want to do is I want to look at some possible questions that we could ask, and then use iNZight to find out the answers. So first question, probably the most obvious. Are you better at the game when the order of the word is statistics compared to stats? So I would think that if the word is forwards, you'd be able to complete it faster than if it's backwards, but we don't know. So if I want to do a hypothesis test on this, here we go. My null hypothesis is that there's no difference between the underlying mean time it takes you to complete the game when the word is forwards and the underlying mean time it takes you to complete the game when the word order is reversed. So there's no order effect. That's my null. Alternative, on two-sided because I don't know which way will be faster. So let's do the hypothesis test. Okay, so let's bring up the data and first round time. Here we go. So we can see it looks like the time is a bit longer for stats and a bit faster for statistics on average. We can look at the summaries, we know this. So we can see the means there, a bit longer for reverse, median, a bit longer for reverse. We can look at the shape of the data. So for both, we've got positive skew. Probably kind of the interesting things. When we click on inference, that's when we get to do our hypothesis test. So let's have a look. First, we get some confidence intervals for the means. So for each group, we get the mean and the lower and upper limit for a 95% confidence interval. Then we get a confidence interval for the difference, the size of the difference between the means. So that's the estimate. Lower limit, upper limit. And we can see the lower limit never gets down to 0. So for our two-sample t-test, as expected, a p-value below 0.05. We just did everything on one screen. We've also got our t-test test statistic and our degrees of freedom. And you can see this calculation, it's not exactly what we would get if we did the calculation for degrees of freedom by hand. We would never end up with decimals, but iNZight's doing a slightly more complicated calculation. This is what happened, right? We looked at the data. It looked like there was a difference. Yes, it kind of did. But then we tested it and we got evidence, strong evidence, very strong evidence, that there is a real difference. We even told the hypotheses in iNZight. We've got a confidence interval for the size of that difference. And based on how the study was carried out, we can think about who we can generalize to. So we don't have a random sample, but we did have random allocation for this to be your first round or this to be your first round. So we do have an experiment. So we can say that the difference in times is caused by the order, the word order. Okay, so I just did a hypothesis test, just like that, real quick. Let's do another one. Okay, are you better at the game when you play on a phone or tablet compared to laptop or desktop? And again, my thinking here is touchscreen is going to beat mouse clicking. Similar kind of null hypothesis, similar kind of alternative hypothesis. Let's go get the data. So we want device type. Oh, need the plot. There it is. Again, both are showing positive skew. Does look like maybe you're a bit slower on desktop compared to mobile or tablet. It's hard to tell from the plot. Could be pretty close. Summary, median a bit higher, mean a bit higher for desktop. Let's do the test. There we go. The difference between the means, it's all in milliseconds. So 3000 milliseconds is our estimate. Could be as small as 600, but not 0, or as high as 5700. P-value less than 0.05 as expected, and this here gives us strong evidence against the null hypothesis that the true difference is 0. Okay. Boom, 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 boom. Right. Hypothesis test. The difference here, I've written we don't have an experiment. And the reason we don't have an experiment is, even though it was an experiment for the last one, the condition that I'm looking at here, device type, was not randomly allocated. You chose to use a laptop or desktop or a mobile or a tablet. So this is no longer causal. I also don't have a random sample, so I can't generalize this to anyone other than the students who played the game. So I can say that I've got strong evidence of a link between device type and game time, and that for these students playing on a desktop had a longer time. I can talk about the size of the difference, like how much does it slow you down by playing on a desktop. Let's do another one. Okay, so most of the examples we looked at in chapter 7 were 2 sample t-tests on means. We also did proportions, but we don't actually have to stop there. So here's an example of a 1 sample t-test on a proportion. So I want to know, are the majority of students tired? So this data was collected back when students were turning up to lectures, and some of the students would have been in my 8 AM lecture. So I'm thinking there's going to be a lot of tired people. So how do I write my hypotheses when I want to know, are the majority of students tired? So my null is that it's 50-50. 50% tired, 50% not tired. And my alternative is that it's not 50-50. Let's have a look at, so we only want 1 variable this time. Okay, so it looks like a lower proportion of students are tired than not tired. So this is both categories, just okay and wide awake put together. So I think if my null hypothesis is that this proportion equals 50%, looks like we've got some evidence against that. Looks like it's actually quite a lot lower. How much lower? It's only 37%. Here we go. So 37% could be as low as 32 or as high as 41, but it's not going to be 50%. So our p-value, note the e minus 0.07, that tells me I've got a very, very small number. So I take the decimal point and jump it back 1, 2, 3, 4, 5, 6, 7. So it's a really, really tiny number. So this would round to 0.000. So I have very strong evidence against the null hypothesis that the true proportions of each category are equal. So very strong evidence, they're not 50-50. I haven't got a confidence interval this time, but I showed you an iNZight that I put that confidence interval in for that proportion. Again, not an experiment, so I can't generalize this beyond, well, I can't say anything causal. Not that there's another variable that would be the causing factor, but I can't. And I can't generalize this to anyone beyond the students that played the game. I'm not finished yet, right? I can do this all day. What about, are you better at the game when you're less tired? That makes sense, right? Let's jump over and look at the data first. So there's 3 categories for energy level. And where is game time? So I'm looking at these 3 and I want to know if you're better depending on how awake you are. So my null hypothesis is that it doesn't matter. The game time doesn't depend on your energy level. It doesn't matter if you're wide awake or you're super tired, you'll still play the game just as well. And looking here, super tired, wide awake, that looks similar-ish. So my null hypothesis kind of looks like this. All the underlying means are equal, but now there's 3 of them. My alternative has to be the direct opposite of this. My alternative hypothesis is not going to be that they're all not equal, but that they're not all equal. That sounds pedantic. We do more of this in chapter 8. But essentially, 2 of them could be equal, like these 2 could be equal, but that one could be different. And that would not meet the null hypothesis. Remember, our alternative has to be the complement to the null. It has to be like, if this is one option, this is the other option. There is no third option. So they're either all equal or not all of them are equal. And if they're not all equal, then there's some link between game time and tiredness. So let's test it. We can look at the estimates, all those 3 means. So it looks a bit lower for wide awake. Maybe it doesn't really matter between just tired and okay, but for wide awake, maybe that gives you an edge. Let's see. No, it doesn't. So our p-value is too big. We don't have enough evidence against the null hypothesis. So maybe all the true group means are all equal, or maybe they're not. We shrug, we don't know, and we don't have enough evidence to say either way. Okay. What about this one? Oh, what if we look at energy level by course? So I'm thinking here, like, is there a difference in the energy levels between the 101, 101G students and the 108 students? Maybe 108 students have early morning classes, so they're more used to getting up early. Maybe 101 students often have assignments that are due late in the evening, so they tend to study later at night. I don't know, I'm just making stuff up, but maybe there's a difference. So what I'm actually comparing, I'm obviously not comparing means, something to do with proportions is what I'm comparing. What I'm comparing is the distribution of the energy level. So for 101G, we've got these orange bars, boom, boom, boom. They're pretty close for just tired and okay, but a big dip for wide awake. For 108, boom, boom, boom. So stepping down each time, but again, a bigger step from tired to wide awake. The question is the shape of the blue bars different to the shape of the yellow bars? And we talked about this back in chapter 1. We talked about whether it looks like one variable depends on the other. So if they kind of look the same, doesn't matter whether you're looking at yellow or blue, then it doesn't depend. But if they look different, then you've got some dependency, some link, some connection. So here we go. So our null would be the distribution of energy level is the same. The blue bars and the orange bars are the same. Look at this. Test. So here we go. So it turns out we don't have enough evidence to say that energy level changes with course. Our p-value is too big, and we would say that we have no evidence, or almost no evidence. That's too big of a p-value. So you've just seen, there we go, you've just seen a whole bunch of hypothesis tests, one after the other, boom, 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 really, really quickly. You've seen them in kind of different contexts, like sometimes we're looking at means, sometimes we're looking at proportions, 2 groups, 1 group, 3 groups, whatever, let's go crazy. But I wanted you to see that every time we do our hypothesis test, we're doing the same thing. We're like, does it look like there's something going on here? Does it look like there's a link or a dependency or some kind of connection? Does it look like something changes depending on which group you're looking at or depending on what you're comparing it to? And then you look at the data and you think, oh, well, maybe it does look like there's something going on. And then you test it. And sometimes it comes out with evidence that you can say that something's going on. Other times you don't get sufficient evidence. So here we don't have enough evidence that anything's really going on. And then if something is going on, usually we'd have our confidence interval up here. So we'd want to know, well, how much? How much does this matter? And our generalizability ideas say the same. If we have an experiment, we can start talking about causality. If we don't have an experiment, we can't do that, but maybe we have a random sample, in which case we can generalize our results to a wider group. If we don't have that, we can't do it. So my challenge to you now, I think you should go and play at this link with the data at iNZight. Think about something that you want to know. You've played the game. What do you want to know? What's the question you're asking? What would the hypotheses be? And you can see when you go into iNZight, it will give you the standard hypotheses, but think about them in terms of what you're looking at and whether they make sense. Look at the p-value. What does it tell you? And remember, the p-value always tells you the strength of evidence against the null. So put it together in a sentence. I've got a really small p-value that tells me I've got strong evidence against my null. My null says that the means are the same. I've got strong evidence the means are not the same. What about generalizability? How would you conclude your investigation? But go have a play. This is your opportunity to really test out what you know, see if you've kind of got a good enough understanding of hypothesis testing that you can just freely go and make one up on the fly. If you can, that's going to be amazing, because in Chapter 8, we're going to look at some of these different types of hypothesis tests, and we're going to be using not iNZight, but we're going to be using software to do all the grunt work, all the calculations for us. So we just need to be able to go through the basics. Okay, so once you've had a play, click on the next video, and we're going to go through the first example in your lecture book.